Welcome to Amplified Education, your exam prep friend. Today we are looking at vertical projectile motion. Please pause the video and try the question on your own. The question reads, Kevin is on an elevator which has a constant vertical velocity of 5 meters per second upward. As he leans over to look below, his 500-gram cup falls off. At this point, he is 8 meters above the floor below, and the collision between the floor and the cup takes 0.025 seconds. The first question says, determine the velocity of the cup at the moment it falls off. So 1.1. That would be, according to the given information, 5 meters per second upward. The reason it's 5 meters per second upwards is because if the cup is in a moving lift or elevator, then it has the momentum or the inertia of the elevator. And so it continues to, so even if it falls, it doesn't fall at 0 meters per second. It falls at 5 meters per second because that is the original velocity of the lift. So it's because of inertia. 1.2 says write the magnitude and direction of the acceleration of the cup at maximum height. So at maximum height, we know that is the turning point of the cup before it actually starts accelerating downwards. So at that particular point, the velocity is 0, but the acceleration, the gravitational acceleration is 9.8 meters per second squared, and that is acting downwards. 1.3 says calculate the maximum height reached by the cup above the point where it fell off. Okay. So I would like to draw the scenario here before I actually continue with this question, right? So at this particular point, the lift is 8 meters, or the elevator is 8, or is it 8 meters? Yeah, it's 8 meters above the ground. So the ground is here. And this is where the cup is falling off. But we know that it just doesn't, straight away go down because it had momentum. So it first goes up a bit, right? So it goes up and then reaches that maximum height, the turning point, and then it starts going down, and then it would hit the ground there. Okay, so it goes up at 5 meters second. Its velocity at max height is equal to 0 meters per second. So that's pretty much what's going on there. So the question says you must calculate the maximum height reached by the cup above the point where it fell off. So that is only above the point where it fell off. So in that particular calculation, we do not need to add the 8 meters because the question does not say above the ground. It says above the height or the point where it actually fell off. So looking at the information, so if you write down the information that you are given, okay, let's write down the given data, right? You have VI, which is 5 meters per second. Then you have VF, which is 0 meters per second. And you are looking for the height. And you have G, which is 9.8 meters per second squared. So that's enough information for you to actually solve the problem. Remember, you need to choose a reference direction. So I'm going to choose up as positive, right? Choose up as positive, right? And if I choose up as positive, if the object is moving upwards, then my velocity should be in these formulas, these equations of motion, should be substituted as positive. My value of acceleration or value of g must be substituted as negative. That is very, very important. And obviously, my displacement when the object is going upwards should be represented as positive. Very, very important. So with that being said, I'm going to use the formula Vf squared equals Vi squared plus 2Gy. And at maximum height, the velocity is 0. So that would be 0 squared into 5 squared there plus 2 negative 9.8 y. So I'm just going to put that in the calculator. That will be, all right, divided by that. The answer that we are getting here is 1,28. So 1,28 meters. So this cup reaches 1,28 meters above the point it fell on. That's pretty much what you would do there. And yeah, obviously, if they said the height above the ground, you would have to add the 8 meters. Okay, so I'm just going to leave that answer at that. Then I'm going to move straight to 1.4, where it says determine the time taken by the cup to hit the floor. And this is 4 marks. Obviously, there are 2 ways of doing this. We could do it in part, or we could just do it straight away. We could just do it, just straight away. I'm going to do the 2 ways of doing it. So the first way we could do this is we could say y equals VIT plus a half GT squared. That's what the formula says. And we know that the cup is released from a height of 8 meters. Okay. So I'm going to substitute there, particularly negative 8 meters. And the reason why I'm doing that is because in my calculation, I am not considering the displacement above that point. So I'm considering the displacement of the cup going down. And the reason why I'm doing that is because remember time symmetry and all of that. The time it takes the watch to, not the watch, the cup to go up should be the same as the time it takes for it to go down. The same applies for displacement. The displacement going up is the same as the displacement going down. So there's no change there in position. So I'm not considering particularly that part in that mathematical expression, all right? That's why I'm substituting negative 8, and I'm not considering this particular displacement that I calculated here, because the reason I'm doing that, because it takes positive 1,28 meters to go up, and it takes negative 1,28 meters to go down. So from there, where the cup actually falls to where it comes back there to that original point it fell off, there is no change in position. All right. I will consider those displacements for the second option. All right. For the first option, I'm not going to consider that. So I'm going to want to set up an equation, and from the look of things, I'm going to set up a quadratic equation. So when I substitute the negative 8, okay, the negative 8, and then what I'm going to do is that I remember I do know the velocity at which the cup falls. It's 5, right? It's 5 meters upwards. I do not have time, and I'm going to say plus a half, right? Negative 9.8. Remember, I chose up as positive. And so G, my value of G must be substituted as negative. Just remember that, and then T squared. Then I've set up that equation. I'm almost done. I just have to rearrange that equation into ax squared plus bx plus c equals 0. Then I'll use my a, b, and c value to find time. Okay, that's all I simply need to do. So what I'll do is that I have negative 4,9 t squared plus 5t. Then I'm going to bring the 8 over, and then I'm going to have plus 8, and I'm going to equate everything to 0. So my a value is negative 4,9. My b value is 5, and my c value is 8, right? So then I'm just going to solve for that. Remember, you can solve for that if you're obviously not carrying a white calculator. You could say x is equal to negative b plus minus the square root of b squared minus 4ac over 2a. You could take that root. It takes forever to do that, right? So my intention is really not to do that, but to just use the white calculator, okay? And that's why the white calculator is available. We could simply just use that and quickly find our answer, all right? So I'm going to go shift mode. Let me just give me a moment. Let me put that in. All right. Shift mode. Shift alpha mode. Then the equation is number 5. Then I'm going to choose the quadratic equation option 3. My value of A is negative 4,9, right? My value of B is 5, and my value of C is 8. So the first value of X that I'm getting, which is time in this case, all right, it is 1,89 seconds. Or my second value is negative 0,87 seconds. We can readily tell which answer is correct here, right? That's the correct answer, obviously, because time cannot be negative. But we can prove that, right? We can prove that by doing the other method. So what we can do is that we can calculate the time it takes the cup to reach its maximum height. Then from there, calculate the time it takes for the cup to hit the floor. So to do that, we could use VF equals VI plus AT. At maximum height, the velocity is 0. The cup fell at 5 meters per second plus negative 9.8 T, then solve for T, right? So that is T for the object while it is going up, okay? So that would be negative, let me just go back and just reset my calculator. So that would be negative 5 over negative 9.8. That gives me 0,51. So that is 0,51 seconds. But that's only the time it takes for the watch to get to the highest point. Okay. Now I'm going to calculate the time from the highest point to where it hits the ground. To do that, I'm going to use x. Should I use x? No, x equals, no. Let's rather use y because we are dealing with vertical motion. So y is equal to VIT plus a half GT squared. So at maximum height, the total height above the ground is 8 plus the 1,28 I found earlier on. That is equal to, at maximum height, remember the velocity is 0. So that whole portion is 0 plus a half, negative 9,8. Sorry, let me just do this, write it properly. Negative 9,8 t squared. Now, what I must be careful of is this, is that my displacement from the top to the bottom should be represented as a negative number because I chose down as negative. And so if I punch that in the calculator, this is what I get. Okay, let me do this. Then we divide by that 4.9. So what I then get now is, right, 1,89 for t squared. So for t squared, I get 1,89. And obviously I'm looking for t, so I need to find the square root of 1,89. And for that, I'm getting 1,375. I'm getting 1,375 seconds. Now, all I need to do is to add that time and this time. And if I don't get this answer or an answer close to this, then it means our method is incorrect. So the total time, let's just call that t tot, is equal to 0.51 plus 1,375. And if we add those two numbers together, okay, I get 1,885, which is 1,89 seconds. So you would notice that the first method and the second method gives us the same answer, right? You can choose any of those methods. The first one is quicker, and yeah, only if you know how to use your white calculator. Then 1.5, I'm just going to write that here to keep everything on one screen. It says how far apart are the lift and cup when the cup hits the floor. So what we are looking at here is that we have to look at the total flight time of the cup and see what distance the lift covers in that time. So for that, we could say x equals vt. We already know that the original velocity of the lift is 5, and the total time here that we calculated was 1,89. And so in that time the cup falls, the lift covers 9,45 meters. All right. So that's from the time the cup actually fell. So we know that the cup fell 8 meters above the ground. Then the elevator continued to travel there for an additional distance of 9,45 while this thing was actually falling, all right, while it was falling. And so if we add those two numbers, the 8 meters plus the 9,45 meters, we get 17,45 meters. That's pretty much how you will do that. Because remember, that's the total flight time. That total flight time includes this portion. It includes this portion of the motion. All right. So that means in this particular calculation, I should not add the 1,28 and the the other 1,28 for time symmetry there. I shouldn't add that there because when I was calculating the distance that the lift covered, I used the total flight time, all right, and not the time from this point here to the ground. That's pretty much how you would look at that. And then if we look at 1.6, 1.6, it says calculate the net force exerted by the flow on the cup. Remember, we know that the collision between the cup in the flow is 0.025, and we know that the cup comes to rest. And so what we need to do there, 1.6, right, is to say F net is equal to obviously MA, and that F net is equal to M change in velocity over time, and that is equal to M V final minus V initial over time. And the mass of the cup would be 500 divided by 1,000, which is 0.5 into, the cup comes into rest, 0 minus, we need the velocity with which the cup actually strikes the ground. All right, so I need to calculate that here on the side. To do that, I'm going to use the formula VF squared equals VI squared. Let me just put it all under a square root anyway. So VI squared plus 2GY. Then I'm going to substitute, let me use maximum height. Let me just use maximum height. I'm going to substitute 0 squared. So, and then plus 2, 9.8. And from maximum height, it was 8 plus 1,28. Okay, so I'm just going to say 8 here plus 1,28. All right. So to find the velocity with which it hits the floor, I'm taking the point of maximum height to when it hits the floor, and I'm substituting 0 as my initial velocity because that's the velocity at maximum height. That's pretty much what I'm doing there. Okay, so the velocity at which it hits the floor, so it will be the square root of 2, and you multiply that by 9.8, and you multiply that by 9,28, 9,28, and you get 13,49. So 13,49 is the velocity at which the cup hits the floor. So that is 0.5 into 0 minus 13,49, close bracket there, divide everything by 0,0025, right? Obviously, this force would be upwards because the floor is exerting a force on the cup upwards. Let me see the time, double check the time. It is 0.0025. So let's just punch that in quickly. So that is 0.5 into negative 13.49, close bracket, open bracket, 0.0025, close bracket. And then what you get is 226. 26. Oh no, it's not 26, it's 2,698. Okay, 2698. Okay, upwards. Obviously, your answer is negative, but I'm just taking a shortcut there and just wrapping up everything there, right? It's like that. Then obviously the last two things, 1.7, you have to draw a VT sketch graph. Okay, let me do that there and try and save space for the last question, which is 1.8. So this is a velocity versus time sketch graph, but for both the cup and the elevator, both the cup and the elevator. So for the elevator, we know that the elevator, remember, we chose up as positive. So we know that the elevator continued at a constant velocity upwards of 5 meters per second. So that would represent the elevator, shows constant velocity. And then for the cup also started at the velocity of 5 meters per second. Then it went up. It reached maximum height here, where its velocity was 0. And then it turned. It reached its turning point here and then accelerated downwards, and it hit the floor at negative 13.49 meters per second. That's pretty much how that, those graphs would look. And then I'm just going to try and fit the position versus time graph here. So that would be x versus t, right? That's your x versus t graph. And so that particular graph, again, very, very interesting because remember, we chose up as positive and the lift continues at a constant velocity. Now, a constant velocity on an xt graph is represented by obviously a line that has a constant gradient. So the gradient of this line would be equal to 5 meters per second, basically. All right. And then lastly, what's this thing now? The cup, right? Remember the cup? The cup first goes up, right? And it's slowing down, and we chose up as positive. So I'm gonna just use a black pen. So the cup goes up first, like this. Okay, it reaches maximum height, and then it goes down, and then it reaches. Remember, the cup was dropped from here, all right, and then it went up, reached maximum height, then it came back to where obviously it was dropped, and then it went straight down, and then it hit the floor here. So essentially that would be -8 meters, right? And pretty much that's how you draw the graph that represents the motion, the xt graph that represents the motion of the cup. And obviously, according to this, the reference point is where the cup actually falls. That's the reference point. Okay, and that's the elevator. All right. I hope that helps. Thank you.